Now friends, in this session I will be trying to explain the divisibility rules, not just the line, what is the divisibility rule, the formula or the rule, whatever it is, not just a single sentence, but we will try to discuss the divisibility rules along with their logic. Okay, what is the real logic behind the divisibility rules, how the divisibility rules are being framed, okay, are formed. Now clearly, first I will go for divisibility rule of 2, 4, 8, 16, 32, etc. etc. You may ask me, sir, why you have taken this, why you are not taking in the serial order like 2, 3, 4, 5 like this? Because they have a logical link between them. That's why we are discussing in this manner. 2, 4, 8, 16, 32 have almost the same logical link as far as divisibility rules are concerned. Okay, what is that? I will tell you. 2 can be written as 2 power 1, 4 can be written as 2 power 2, 8 can be written as 2 power 3, 16 can be written as 2 power 4, and 32 can be written as 2 power 5. 32 can be written as 2 power 5 and so on. So that means all these numbers are nothing but exponents of 2. Exponent can be written as exponents of 2. Okay, so 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, etc. etc. Actually, the real logic lies in that powers only, exponents only, 2 power 1. So that's why, for example, I say, if any number, take any number, if the last digit is 0 or any number you find which is divisible by 2, then that entire number is divisible by 2. Why? Because 2 can be written as 2 power 1. That means starting from the units place, the logic will start. Suppose 4, what people say? 4. If any number should be divisible by 4, the last two numbers. Okay, why? Because, why they are telling about the last two numbers, last two digits, places, that means units place number and the tens place number, because 4 can be written as 2 power 2. Okay, this exponent will decide from the units place how many slots or how many places we have to check, we have to consider for the divisibility rule. So that is why whenever these numbers are coming, the actual logic lies in their exponents of 2. They can be written, whenever any number can be written as an exponent of 2, that exponent decides what is its divisibility rule. Now we will see one by one, what is the divisibility rule of 2, 4, 8, etc. etc. right? Now divisibility rule for 2 power 1. For 2 power 1, that means 2. Friends, any number, you take any number. You can take any number of any size. Our point of concern is only what is the units place. In the units place, since divisibility rule for 2 I told, that means 2 can be written as 2 power 1. That means starting from the units place, you have to consider only one place. That means only units place. In this place, if there is 0 or there is 2 or there is 4 or there is 6 or there is 8, any size number, in the last place 0 is always involved. Okay, because 2, any number ends with 0, that is divisible by any natural number other than single digit 0, 10, 20, like that, any such kind of number is divisible by 2. Okay, now that means 0, 2, 4. In a natural number, in the units place, if you find 0, 2, 4, that means 0 or any number that is divisible by 2, that entire number is divisible by 2. In the same way, now logic for 4 also continue. That means divisibility rule for 4. Divisibility for 4. 4 can be written as 2 square. That means the logic lies in last two places. 2 is the power. That means last two places. Okay, that means you take any number. Any size number you take, no problem. Last two digits will decide. That means if the last two digits are zeros, or it can be 4, or it can be 8. 8 means 08 I am writing, or it can be 12, and so on, up to 96. So you take any natural number, last two digits can be 0, two zeros can be there, or any number, any 2-digit number, or any 2-digit number which is divisible by 4. That means it will start from 04 to 96. That the entire number will be divisible by 4. No need to check the full number. That entire number is divisible by 4. Why I am taking last two slots? Because 4 can be written as 2 power 2 and power is 2. That means that power is telling last two places from the units place, two slots you have to check. Okay, that is the logic behind it. Now we will discuss for 8 also. Friends, now coming to divisibility rule for 8. So as I said, 8 can be written as 2 power 3. That means the power 3, that the 3 will decide what is the last 3 places. Any number, any size number you take, last 3 digits. That means the last 3 slots can be zeros, or any number, any 3-digit number that is divisible by 8. So it means it can be 008, it means it can be 016, or it can be 024. Like that, it can continue up to last 3 digits can be 992. Okay, 3 zeros, last 3 digits can be zeros, or any number which is divisible by any 3-digit number that is divisible by 8. So same thing goes for 16 also. So divisibility rule for 16. 16 means I can write it as 2 power 4. That means 4 places. So any size number you take, last 4 digits will decide. Last 4 digits can be zeros, or it can be 0016, or it can be 0032. Like that, so on. It will go up to. So it will go up to 9984. So it will go up to 9984. Like this, how the divisibility rule of 2 power 1, 2 power 2, that is actually exponents of 2. Actually, we should call it as divisibility rules for 2 and exponents of 2, and the multiples of 2 with their exponents. Okay, so 2 power 1, 2 power 2, 2 power 3, 2 power 4, like that. The actual logic in the divisibility rule goes. Okay. Now this is the fact. Now 2 power 5, that means 32, how can we write 32? 32 can be written as 2 power 5. That means the actual logic lies in last 5 digits. This is how the divisibility rules of 2 with exponents 1, 2, 3, 4, 5 goes on. Now friends, we will be discussing about the divisibility rule for 5 and 10. Of course, you know it is very easy. So first I will tell the divisibility rule for 5. So any number, any size number in the units place, if you find 0 or 5, if you find 0 or 5, then that entire number is divisible by 5. So in the units place, 0 or 5. If you find 0 or 5 in any natural number, if you find 0 or 5 in the units place, then that entire number is divisible by 5. Now coming to 10, you take any number in the units place, if you find 0. No matter what are the remaining numbers, in the units place, if you find 0, in the units place, if you find 0, then that entire number is divisible by 10. So in the units place, if you find 0 or 5, then that entire number is divisible by 5. So these are the divisibility rules related to 5 and 10. Now, just now I have discussed the divisibility rule of 2, right? So 2 power 1, 2 power 2 are with their exponents. 2 power 1, 2 power 2, 2 power 3, 2 power 4, etc. Now, I have told you the divisibility rules of 5 and 10. Of course, I know these are very easy, but there is a question in an exam which was asked by combining both these rules. Okay, what is that problem? We will be seeing now. For that purpose only, I told you this divisibility of rule with their exponents and divisibility rule of 5 and 10 at a time. So we will be looking into that problem now, which was given in an exam. Friends, now we will be looking into this question. Before going for that exam question, a sample question I am dealing with the divisibility rule of 8. Okay, so divisibility rule of 8 means 8 can be written as 2 power 3. That means last 3 places we will be considering for the divisibility rule, right? Now what least value must be assigned to star symbol so that the entire number 63576 star 2 is divisible by 8. That means if this entire number should be divisible by 8. So then in that condition, out of these 4 options are 1, 2, 3, 4. Out of these 4 options, which number must be placed in the place of star so that the entire number is divisible by 8? Friends, clearly I can see here the number given is 63576 star 2. So we will take these 3 numbers only, 6 star 2. So there are only 4 options, we will check and we will see. So 612, it can be 612, it can be 622, or it can be 632, or it can be 642. Okay, so clearly if this 3-digit number, if any of these 3-digit number, obviously that is a multiple choice question MCQ, only one right answer will be there. So here 612, 622, 632, 642, whatever the number is divisible by 8, so 3-digit number is divisible by 8, then this entire number will be divisible by 8. So we can confirm, we can finalize that number as a number which is entirely divisible by 8. 612, is 612 divisible by 8? So 8 7s are 56, 56, 52, no, it is not divisible. 622 again, 8 7s are 56, 62, no, it is not divisible. 63, coming to 63, first of all 63, 8 7s are 56, 63 minus 56, how much? 72, yes, 8 9s are 72, this number is entirely divisible by 8. 632 is entirely divisible by 8, 79 times it is going. Okay, 642 is also not divisible, you can check. 642, 8 8s are 64, then 2 is not divisible, okay. So exactly the number which is exactly the 3-digit number out of these 4 options which is exactly divisible by 8 is 632. 632. So what is that number that we should write here? So if we place this 3 here, that means 6357, 6357 632, 6357 632, this number, entire number is exactly divisible by 8. Okay, so what is the correct answer? Option C is the right answer for this question. Now friends, have a look at this question. This question is having combination of divisibility rule for 8 and also 10. Okay, based on both. This question is designed based on the divisibility rule of both 8 and 10. Let us read the question first of all. If x and y are the 2 digits of a number, okay, if 2 digits of the number, say this here and x and y of a number 3, 4, 7 x and y, that means y is the units place number and x is the tens place number, clearly we can see, such that the entire number is completely divisible by 80. The entire number is completely divisible by 80, then what is the value of x plus y? So what is the sum of unit digit number and tens digit number also they are asking. There are 4 options given to you, 2, 4, 6 and 8. Friends, clearly it is given here 3, 4, 7 x and y is the given number. 3, 4, 7 x and y is the given number. And one more thing is that they are telling this entire number is divisible by 80. Friends, you know very well, if a number is divisible, if a number is divisible by a divisor, okay, then it will be divisible by its factors also. That means suppose if this number is divisible by 80, so what are the factors of 80? So 8 and 10, so 8 or 10 se bhi divisible hoga. No doubt about that. So this number will be divisible by, because 80 is nothing but product of 8 and 10. So this number compulsorily it should be divisible by 8 and also by 10. Okay, then only it is possible. So now coming to 10, because the divisibility rule of 10 is very easy. So last digit must be 0, then only that entire number will be taken as 0. So this number is nothing but y's value is nothing but 0. Y's value is nothing but 0. Now what is the status? 3, 4, 7 x 0. Now x, we have to find the value of x and then we will go for, now we know that y is equal to 0. Y ka value to aa gaya. So that means y is equal to 0. Now we have to find the value of x. What is the value of x? So here another thing, it is divisible by 8 also. Since it is divisible by 80, so it should be divisible by 8 and also it should be divisible by 10. So now what is the rule of divisibility rule for 8? Last 3 digits हम consider करेंगे. Last 3 digits हम consider करेंगे. That means 7x0, if that number is divisible by 8, if that 3-digit number, if 7x0 is divisible by 8, then the entire number is divisible by 8. Clearly anybody can say by looking at these options, sir, 2, because if I put 2 in the place of x, it will become 72. 72 is clearly divisible by 8. 8 9s are 72. So 8 is 72 and 0. Anyway, we know that 0, 10 is divisible. So 720 will be definitely divisible by 8. Now that means the entire number is coming as 34720. 34720. This is divisible by 80 and it is also divisible by 8 and 10. If you want, you can check individually. 347. So what is the value of x? 2. So y's value is coming as 0. So y's value is coming as 0 and 2's value, x value is coming as 2. So that means what is x plus y? X plus y is 2 plus 0. Obviously the answer is 2. Answer is 2 because the other value is 0. So option A is the correct answer for this question. In this question, we have, that means this is how this is a previous question. This question is a previous question for an exam, for a competitive exam. Okay.